Up until now, we've been working with our hardware that has our 3 LEDs. And the last part of the section, we're going to look at one more thing that we can do with it. So you may have been thinking, wow, these 3 LEDs blinking, it's kind of like a disco. I wish I could take this with me and show it off to my friends when we're partying. But maybe you've got 2 sets of friends, one set of friends who are into raving, and the other set of friends who are into the waltz. And you can't really have the LEDs blinking that fast for a waltz. But when you change the speed of the blink, you don't want to have to upload the sketch again each time. So in this section, we're going to look at how you can change the configuration or settings of a sketch from the serial monitor without having to upload a new sketch each time. And then we'll also look at how we can store those settings so that even when you turn the power off, you have the same settings when you turn them back on. So let's return to the sketch that we have from the section that we were looking at learning about for loops and arrays, and we'll pick up from that code there. So let's take a look at that. So hopefully you saved it with a meaningful name like my blink without delay with array example, or maybe even something shorter. So let's have a look at the code that we're going to want to change. Now, we're going to want to do a number of steps. We want to be able to read the value from the serial monitor, and then we want to use that value to scale the interval that we're waiting to blink the LED. So the first thing we want to do is make sure that we've got the serial monitor initialized, and we've got that here with serial.begin 9600. So now we no longer need this line because we won't be printing random numbers to the serial monitor. Now, the first thing we need to do is say, well, we're going to be storing a value that will be the scale. So we need to make sure that we have somewhere to store that. So let's go ahead and make an integer variable called scale, and we'll give it an initial value of 1. Because if we haven't asked for the speed to be changed, then we just want our default speed. And then the next step that we want to look at is how do we read a number from the serial monitor. Now, if you want to find out whether such a thing is possible, then you can take a look at the Arduino language reference. And this is always a good idea if you want to find out how to use a particular part of the Arduino language. So we can see in the communication section, it documents the serial object. And then it has a list of the functions that are available on it, and one of those is parseInt. So that reads an integer value from the serial monitor. So let's go ahead and use the parseInteger value. Now, one thing that we need to keep in mind is that sometimes we might actually want to check a value before we use it. Let's just go ahead and use it right now. So we can go scale equals serial dot parseInt. So this says read a value from the serial monitor and put it into the scale variable. And then once we've actually got our new value, we want to be able to use it. So we want to put that in here to increase the size of the interval from whatever the default is for that pin, for that particular LED. You really want to save that with a different name, so let's do that now. And upload it. Now, once we've uploaded it, you'll see that, in fact, our 3 LEDs are now blinking all at the same time. So obviously, there's a problem with the code that we've written. As it turns out, if we need to think about how the parseInt function works. And how it actually works is that it looks to see if there's a number sitting in the serial monitor, and then if there is, then it extracts it from it. But what happens if there isn't? Well, in that case, it waits for a certain amount of time and then goes, oh, okay, there's no new number, just carry on. Now, the problem with this is that obviously affects the rate at which we can blink our LEDs. And that's an important thing to remember when you're using the technique of not using delays for the blinking, but to keep track of time. So anything that happens in this section which needs to be running all the time needs to not take too much time itself, otherwise it will affect the speed at which the LEDs are blinking. Now, as it happens, there's a way that we can work around that. If we look at the serial object again, we see that there's a method called setTimeout. And this allows us to say the maximum amount of time that the serial monitor should wait before carrying on and assume that there's no new input. And so we can see here that by default this is 1,000 milliseconds, which is a second, which is far too long to not interrupt what we're doing with our blinking. So we need to change that value in our code. So because we only need to do it once, we can put that in the setup section. So we want to say setTimeout and then give it a really small value so that it doesn't interfere with the blinking. So let's say 10 milliseconds. So we save this and then upload it again. So you'll get used to the cycle of modifying a sketch and then trying to find out if something doesn't work as you expect, find out why it's not working. Now, as it happens, we're still getting a situation which is not what we're actually looking for. And that's that now all of our lights are on and they never turn off. Now, the reason for this is you need to step back and think for a moment about how the Arduino is actually processing this code. So when it gets to the parseInt section, it reads a number if there's a number there. But what happens if there isn't a number there? In this case, if we hit the timeout, so that 10 milliseconds has passed and we don't have a new number, something is returned from that function, but we don't actually know what it is. Now, often you'll find that if you look in the reference, it will tell you what happens in the situation where an unexpected or the non-typical result occurs. Now, as it happens, in this case, parseInt doesn't actually tell us. But from experience, I can tell you that if the timeout is hit and there's no new number, then parseInt returns a 0. So the reason why the lights are on all the time is because the interval has been multiplied by 0, which means that there's no wait at all. So the LEDs don't actually stay turned off for any longer period of time. Now, if you find that the documentation isn't quite as clear as you would like, or if there's a little bit of information missing, it's a good chance for you to go to the Arduino issues tracker and just record a bug there that says, hey, the documentation here doesn't mention what the default value is. And that's part of the great thing about the fact that Arduino is based on open source software is that you can go and put a bug in, and you can even, if you like, submit some suggested text and say, hey, it would be really great if this here said, if the timeout is hit, then a 0 value is returned. And then maybe your suggestion will be incorporated into the documentation for a later release. So let's go back and look at our code. And think, okay, so what's going to happen here if we get a 0 value? So obviously, if our scale gets a 0 value, then at this stage, our interval will be reduced to 0, and that's not what we want. So we need to store the value that's returned from the parseInt function in a temporary variable so we can check to see whether or not it's a number that we're expecting. So let's go ahead and change this code and create a new variable called newScale. And because we're only using it within this loop, then we can just define it here. So this means that we'll have a value from the serial monitor which is put into newScale. And then we want to see whether or not that newScale value is something useful. So we want to know that it's greater than 0. So we can do that with an if check. So we say if newScale is greater than 0, then we actually want to store that value in our scale value. So we go scale equals newScale. So this means that if we don't get a number from the serial monitor, new scale will be 0, so this won't succeed, so this code will be skipped and we'll just go straight to here. But if new scale is, say, 1, then it will be greater than 0, and so we'll assign the new scale value to a scale variable, and then it will work there. So let's verify that that is what happens, save it, and upload it. So we're uploading it again, and now it looks like we have success. We have a rapidly blinking blue LED, a slower blinking red LED, and then a much slower blinking green LED. So we know that with our change, we haven't broken the functionality that we had before, but we don't actually know if our new functionality worked. So let's check that out. Open up the serial monitor, and then enter in a number. So let's try and make it something really noticeable and say make it 5 times slower. So we can hit send, and then we immediately see the result with a much slower blinking blue LED and a really slow blinking red LED, and then a really, really slow blinking green LED. And if we think, well, that'll be great for the waltzing, but I'm going to go see my raving friends now, you can also set the scale value to 1 and return it back to its original speed. Now, the problem with this method is that if we say, okay, well, let's go visit our waltz friends and slow it down, and then we might say, okay, we'll unplug it, go to our friend's place, put the battery power in and come back, and then when we plug it back into the power, it's returned back to the fast speed. So that's an important thing to know, that any change that you make in the configuration in this way doesn't get preserved when the power is removed and reapplied. So we need to have some way of storing the value so that we can use it later. So we're going to have a look at that in our next segment.